Welcome back to Maths with Mrs. J. We've been talking about factorisation and the fact that factorisation and expansion are doing the opposite things. When you're expanding, you're going from a product to a sum or difference. And when you're factorising, you're going from a sum or difference to a product. Now, today I wanted to talk about perfect squares. When we did our expansion topic, we learned how to expand these two special expressions here, a plus b all squared and a minus b all squared. You might recall that I showed you this one on a diagram, showed you why that is not just your a squared plus your b squared. You get two extra rectangles coming in there. If you don't believe me still, you can do this. You can do it as an expansion like this with your FOIL. And what's going to happen is you're going to get a squared plus ab plus ba, which is another ab, plus b squared, which gives you your a squared plus 2ab plus b squared. So many people forget that middle term. Please don't let that be you. So that's expanding, but we're now factorising. So we're wanting to go back the other way, which means we need to be able to recognise the patterns that will enable us to do this. Now, the good news is that if you don't happen to recognise the pattern, quite often with these you could still do it using your normal techniques, but what will happen is you'll get two brackets that are the same, and then you'll just need to write that as something squared. It is way better though if you can recognise the pattern, particularly if you are in a solving equation situation, because then the whole completing the square business comes in. So many things in maths are linked to other things in maths. You might think that they're all individual topics, but actually everything is intertwined, which is why it's important that each topic that you do master the skills and you do understand what you're doing. Let's have a look at these examples here and I'll show you how I can tell that these are perfect squares. Okay, first thing you need to look at is the first and last term both something squared? Well, yeah, that's x all squared and that's 5 all squared. So it's ticked that box. So we've got our a squared plus b squared there. So that's all good. Then what we need to do is we need to check, is that middle term 2 times our x times our 5? Well, 2 times x is 2x, times 5 is 10x. So yes, this is x plus 5 all squared. The other way that you can find out that this is a perfect square, and we've done videos on this as well, is by working out the discriminant. If you haven't done that topic yet, don't worry about it, but just for those who have, b is 10, so b squared is 100. 4 times 1 times 25. When you work out your discriminant, you get 0. If you work out the discriminant of any quadratic and it comes out to be 0, you know that that quadratic expression is a perfect square. Okay, so that's a little thing to bear in mind. Okay, let's look at our next one. We've got something squared and something squared, so we're all good there. This term here, is this 2 times x times 3? Well, it is, but with a negative. So that's okay. So this will be x minus 3 all squared. Both our formulae have a plus before the b squared, but whether the sign's positive or negative depends on what's in your brackets there. All right, let's press on. Is this a perfect square? Well, x squared is x squared. 4 is 2 squared. 2 times x times 2, yes, is our 4x, so yes, that's x plus 2 all squared. What about this one? Well, that's something squared, that's something squared. What's 2 times x times 6? Yep, it is 12x, but in this case, we've just got to be careful that we put our minus in our brackets. Now we're getting a little bit more tricky. 4x squared. Well, that's 2x all squared, so that's still a perfect square, and 81 is 9 squared. What is 2 times 2x times 9? Well, 2 times 2x is 4x, times 9 is 36x, so yes, this will be 2x minus 9 all squared. What I'm doing when I'm doing this is 2 times 2x times 9, this term here. What I'm doing is checking that we've got our 2ab situation happening. Looking at this one, well, this is 9x all squared, this is 1 all squared. 9x times 1 is 9x times 2, yep, is our 18x, so we get 9x minus 1 all squared. This one here, well, as it is, no. 3x squared is not a rational number all squared, and neither is 3. However, what have we been talking about in our very first factorisation video? We said that we always take out a common factor first before doing anything else. Now look what we're presented with. That is a perfect square. That is x minus 1 all squared. So remember, common factor first. I can't say that enough. I can't stress that enough. This one here as well, as it is, no, it's not a perfect square. But if we take out a common factor of 5, then we can fairly readily see that this is 2x minus 1 all squared. Okie dokie. Ready for our next video?